All right, so I'm going to give a brief talk here about voting theory. My name is Dr. Adam Graham-Squire. I'm a professor here at High Point University, and voting theory is one of my main research areas. So in most American elections, when you vote, you can only vote for one person. So basically, you go into the ballot box, and you've got a list of people, maybe A, B, C, D. Sometimes there's only two candidates, and you basically just circle one of them. That's what your vote is. You're saying this is who I'm voting for. And if there's only two people running, if there's just A and B, often it's just a Democrat and a Republican, then just voting for one person actually is a perfectly legitimate way to do it. But if there's more than two candidates, voting for other parties, there's a Libertarian Party, the Green Party, Communists, the Rent is Too Damn High Party, those are all actual parties in the United States of America. And oftentimes, if you vote for them, if they don't have a whole lot of support, then you vote for them and your vote goes nowhere because they don't have enough votes to really be competitive against the Democrat and Republican candidates. So the jumping off point for voting theory is, suppose that instead of just circling one of those candidates and choosing one, suppose you could actually rank them. So you might say, well, A is my number one choice, but D, they would be my second choice, B is my third choice, and C is my fourth. And that is called ranked choice voting, and listing something out like that is a ranked choice ballot. So all candidates are on the ballot at the same time, and the voters rank all the candidates instead of just saying this is their top choice. And the idea is that with this greater information of not just who's your top choice, but how would you rank them, you could actually make better choices or more choices, more democratic choices in elections. So let me give you a quick example of what this might look like. If you take a bunch of those votes and compile them all into one spot, that is called a preference schedule. So take a bunch of preference ballots and you get this thing right here. So our first column here, this means that out of the 100 people who voted in this election, and all of my elections for this talk are all out of 100, you can think of them as actual voters, or you can think of them as percentages, either one works. There were 70 people who voted A, B, C, D, first choice, second choice, third choice, fourth choice, and 13 who voted B, C, D, A, etc. So if we were looking at a regular American election, basically the vote tally we would get would just look like this first part that I put in red. We'd only be looking at the first choice votes, and it'd be pretty clear that in this election, candidate A is the winner. They got 70 votes, way more than anyone else. They should win the election just based on first place votes. And looking at the second, third, and fourth choice votes doesn't really help us much because A is still quite clearly the winner. They're way ahead of everyone else. But what if you had a slightly more competitive situation? Consider this election right here. We've got 4 candidates, and in our current election system, if you just look at the first choice votes, you would say, oh, candidate A should be the winner because they got the most votes. But if you look at what the rest of the data that this ranked choice election is telling us, it kind of looks like A is maybe not the best choice because A is at the bottom. They were the last choice for everyone else in this election. You add 28 plus 21 plus 20, and that gets you to 69 people who hate A. They think A is the worst possible choice, and 31 who love A. You wouldn't really want to choose A as your candidate in that case. And another way to think about this is, suppose that in this election, candidate A was a Democrat, and candidates B, C, and D were all Republicans. Well, that makes sense, right? Some people might choose B as their favorite Republican, but they're going to list C and D as the next choice. So we've got 69 voters who are Republicans, 31 who are Democrats. You would want to elect a Republican. So there's one way of dealing with this, one ranked choice voting method called instant runoff voting, which we often abbreviate as IRV. And with instant runoff voting, what you do is you look at this and you say, well, we're going to start by just looking at all the first place votes. If any candidate gets a majority that's greater than 50%, they win the election. Here, no one has a majority, so we look at which candidate got the least number of first place votes. That's candidate D, and we say they are the least liked and we are going to eliminate them from the election. And now, whoever was ranked second on that ballot, they now get those 20 votes. So in our second round of voting, B is now going to have the original 28 votes plus the 20 that got transferred to them. So they've got 48 votes. C has 21 and A has 31. No one still has a majority, so we do one more round. And in our next round, we say who has got the least votes. Well, C got the least, so we're going to cross them off of all the ballots. And these 21 votes that we're going to see are now going to go to B. So in our third round of the instant runoff election, B is now going to have the 48 they had before, plus the 21. They get all 69 of those votes, which would all be going to that Republican candidate. Like I said before, if B, C, and D were all Republicans, A would only get 31 and B would be the winner. So that's one way that you can use the ranked choice voting to give you a better result that you might have comparing to just looking at the top votes. What else? Well, consider this example. Initially, when you look at this, it kind of looks like we don't really need to look beyond the first choice votes. A got 53% of the votes. The next highest person was B at 40. And so it kind of looks like A has a pretty solid win. And that's one way to approach it. But again, if we look here, we see that 47% of the people really hate candidate A. They want A as their last choice. And if you look at the first and second choice votes together, every single person in this election, every voter listed B as either their first or second choice. So it kind of seems like B actually has a lot of support. And is there a voting method that would actually allow us to represent that? And it turns out that there is. And one way to do it is through something called the board account method. And this is actually the same method that's used for a lot like sports things, like Heisman Trophy and stuff like that. This is one of the ways that they do it. The idea for this is when you rank the candidates, that top choice, your first choice, we're going to give them 3 points. So this is a points-based system. For every second choice place someone gets, they get 2 points. Third choice, they get 1 point. Fourth choice, they get nothing. So how many points does A get? Well, A got 53 first place votes. So that would be 53 times 3. That's 159 points. Pretty good. How about candidate B? Well, B had the 41st place votes, so that would be 40 times 3. But they also get, oh, and notice that A, I should have mentioned this, for all their other votes, A just gets 0. So the only place they get votes is at 149. B, however, gets 53 plus 5 plus 2. That's 60 more votes where they were all getting 2 points. And if you add that all up, that's 240 points. So B would get way more points than A, and B would end up being the winner of this election. And in fact, if you do the points for C, C has pretty close to the same number of points that A does. So this is another way of, sort of running the election that would allow us to get, more information and possibly a different winner. And one thing to notice about this is if you did a ranked choice instant runoff election, like I talked about before, you would actually still end up with A being the winner. So what this shows is that with the ranked voting, you can actually get a different winner depending on your different choice of voting method. And one of the big questions you'll be dealing with when you're looking at this material is which one of these methods is the best, which one's better than others and why. And at this point, you might be looking at this and thinking, oh, like this seems to make a lot of good sense. These ranked methods seem like they give you more information. Maybe you can make better choices. But there are some problems that show up, some strange anomalies. And I'm going to give you a quick taste of what one of them is with this ranked choice voting. And this is the election we saw before, where we did the instant runoff election. And when we did that, we saw that B was in fact the winner of the election. And what I'm going to show you is, suppose that right before this election happened, as people were walking to the polls to vote. Two of these voters who had originally planned to vote CDBA, they decided at the last minute, I'm going to change my CDBA and I'm going to put B all the way to the front of the ballot. They just decided as they're walking to the polls, I actually think B is the best candidate, so I'm going to move them up. Now we know that in the original election, B was going to win the election. So you would think that adding a few more votes, even more in favor of B, would actually make them more of a winner. But when you actually run the election, well, now that these have changed, we took 2 away from this column and we added those 2 to the BCDA column. Well, what happens now is that the first person to drop out is candidate C, because they only have 19 votes. So C gets eliminated and their votes go to D. So in our second round, we have that A still has their original 31 votes, B has their original 30, D now has 20 plus 19, that's 39. So who gets eliminated? B gets eliminated. So in that, what we have now is that B, who would have won the election, is now getting eliminated, and their votes go to D. D ends up winning. But the big thing to notice here is we actually changed some votes in favor of B, and that made B end up losing the election. And this is something called a monotonicity anomaly. And it's a rather strange thing that you wouldn't expect that can happen with ranked choice voting. And you'll be investigating more of these types of things as well in this section. And I hope you enjoy it.